let's talk about class for today. So I put two links for files that I think I already sent you guys. These, because Wednesday, we had kind of a very deep lesson that I lectured the whole time. And today's lesson is very light. It is just on talking about outliers and classifying them. So I'm going to assume that you guys were able to read that on your own. I wanted to spend today actually trying to have you guys do some hands-on work, right? Because we're in this linear regression, and I'm hoping you guys are tracking on the concepts of it. But it is now, because R is doing all the heavy lifting, it is more important for you guys to not know how to do the math, but to look at a question, know what you need to tell R to get the correct data. Once it gives you that data, how can you interpret it and explain it and qualify it, right? That is going to be your job, right? And so I would like you guys to look at that, and we're going to open up R and try to work on this, but do not treat it as something that you just need to say silent and struggle on and then either turn it in or not turn it in. This is intended to be instructional. So if something, let me know immediately, whether it's in the direct message or bring it up here in chat. And even if you're stuck, just say, hey, here's what I'm doing. Is this right? And I am equally happy to sit in silence for most of it while you guys work this. If you guys feel good about it, then this is good practice, and I can say, yes, you guys are on track, you're doing good. Or I'm happy to spend the majority of the lesson going through each one of these together in class of how we would do it. So if you look at it and go, this is easy, and you just want to knock it out and just send me the Word document with all the answers, I can look at it and go, yep, you seem like you know what you're doing, and you can take off and spend this class period working on Lab 8 if you need to catch up on that or whatever else you have. But otherwise, I want you to work on that. And you'll understand, look at each of the questions. Most of them have a numeric part, but also a explanation part. And I'm not looking for paragraphs, but I want to make sure you guys understand, like, beta not hat, beta one hat. It's important that you be able to calculate them in R and give me the numbers, but it's also important that you understand what they are and what, if any, meaning do they have, or what meaning do they not have, right? Because I want to make sure you guys understand those conceptual parts and explain it. So look at that, open it up, and then tell me if you guys, as soon as you guys are getting stuck on anything, whether it be opening the files, importing the data, or getting results. And so send me those direct messages as we go here. I will look at them and I will share it in here. If you just want to ask a general question in here, by all means do that, but I will mute otherwise, and I will look at that. All right, and then if you got any general questions, just let me know. I did already get one request to share. I can go ahead and do this and share my screen of the kind of the Word document with the questions. So if you don't want to split the screen, there's no point in looking at my face full screen, since I'm not sharing stuff right now. But here is what we're talking about, to make sure we are on the same page. And in case you're curious, like I said, I pulled this. There's a lot of data in here that you may or may not need. We may come back to it later, but this is basically a pull from IMDb of what I termed blockbuster movies, which are just movies that had a budget of over $50 million. And looking at the revenue, there's a lot of data we don't need in here, which if you get bored, you're more than happy to see if you can find other relationships in here, like, does anything have an effect on the popularity or the number of languages it came out to? Or if you really wanted to, you could look for grepl word. I didn't even do this. You could grepl words in the movie description or tagline and decide, is there some words that you should use in your movie description if you want to get people excited about your movie? I mean, all of this is moot anyway. We're talking about the before times when people actually went to movie theaters. None of it matters anymore now that the world's on fire. I will say on a serious note, speaking of the world being on fire, I don't know if they made you guys all watch the Dean's call, but I will double down on what she said. Things suck and no decision is great right now. And while I hope you guys know I am always available for EI or direct messages, that being said, if you guys ever want to, I'm sure you guys have people who are more interested in talking to me, but if you are in Q&I or you're stuck or they've made a new rule that says you can't look at anybody except your roommate and you just need to talk to someone else, you guys are always free to message me for EI. And if we don't talk about anything on math and you just want to vent slash complain to me, I am always open to listen because I want you guys to know I am your advocate, whether it be for math, but I also want to see you guys graduate. And if that involves like getting stress out, then by all means, yell at me and not your AOC or the dean. I can take it and give you my, because I need somebody to yell at sometimes too. So feel free to use me for that. Okay, so I've had a couple of people who have been saying different versions of that they understand what's doing, but they're having trouble with the code. So as a reminder, we went over some of this on Wednesday. And like I said before, I'm not saying that to say, oh, you should have been listening on Wednesday. I'm saying it to remind you that I should have posted in my instructor folder the slides and more importantly, the code from Wednesday. It was not exciting, but it is there something for you guys to manipulate. So I can, let me share, excuse me. Let me go ahead and share my R screen for you guys. And so this was what we were looking at on Wednesday, right, when we were doing the example of trying to do a regression between GR1 and GR2 scores to see if there's a relationship, right? So we have this plot here, which hopefully you guys feel good about scatter plots now, that you just say plot variable versus variable. Now, I will say what's important to remember here is that the order matters, right? When you say GR2 squiggle GR1, you're saying plot GR2 versus GR1, which means I want to plot GR2 as my response variable to see how it responds to GR1, which means GR2 is my Y and GR1 is my X, right? So in our example, our response would be revenue. There's a lot of reasons for that, how we phrase the question, but also just it makes sense, right? Budget might be a predictor of revenue, but it's not going to go, I can't predict my revenue with budget. But by the time I have revenue, I already know my budget, right? So I want to have specifically make sure order matters. Not only order matters for your plot, but also when you do your linear model, right? This is the money line of code for doing a linear model, right? You're saying some variable equals linear model of, and again, this order is important, right? Because I've seen people do kind of three different issues with this. One, where they have the order wrong on their scatter plot. So their scatter plot looks different. Then the other one I've seen is they do it correct there, but then they change the order on this here for the linear model. And so they have a scatter plot that looks like this, but then a line that doesn't necessarily looks like it matches up, right? Because they are doing a model of the variables in reverse order. So it's not actually modeling the data as shown. And then the last part is where they do both of those correct, but then they will add labels to their model and they will inverse the X and Y labels, right? So all the data is correct, but the X and Y axis labels are off. So always make sure all of those are correct so that your data makes as much sense as possible. And then don't forget that once you have created your model, the nice thing is it's full of all kinds of stuff, but R knows how to pull stuff out. So if you say, show me a summary of that model, it will show you all of kind of the big information that we need here, right? You just need to know how to pull it out. And if any of you are struggling to remember how we pull stuff out of it, let me know and I can happily tell you. And then we can do our diagnostics by just saying, plot that model, right? And again, it's easy to plot it, but then you need to know what these mean and how to interpret them, right? And then if I want to see what it looks like on top of it, I can just do an A-B line. And it knows if I say, hey, do an A-B line, of my model. R knows, oh, he wants me to look inside and grab all the stuff to draw a model so I can see what it looks like. And again, this is not the data we're doing. This was GR versus GR2, but same idea, right? So those were kind of the reminders of looking. If you want to actually toy with the physical code, you can just download it from our instructor folder and grab it out. But those are the general ideas on there. All right, and then when you guys have time, do me a favor. I just put in the chat messages 1 through 10 on there. And if you guys could just give me kind of some feedback on those numbers. I don't care what emoji you put on the number, thumbs up, thumbs down, smiley face, puke face, whatever, to indicate which problems are the ones that you are struggling with, so that I can kind of get an idea of where we're sticking at. So if there's particular ones that you're don't know where to start or struggling with, just put some emoji on that number, so I can kind of get an idea of where to focus, what are the concepts that you guys are challenged with. Okay, so you guys are not alone. So far, I had 2 sections, and 5 and 6 have definitely been popular in the same way that Dean's call and the superintendent's announcements have been popular. So here's the short version on that. 6 is a bit of a cheat. So 6 is based on something we talked about in the lesson on Wednesday, and it requires no math, right? This was more of a question just to see if you were paying attention to the concepts, and if you weren't, it's fine. We had a lot of stuff there, but it's the idea of, it's one of the it's one of the nice aspects of doing a linear squares regression to find a best fit, because there are multiple ways to find a best fit. So one of the reasons we do a least squares regression is that it has this nice artifact of it, that when we get a line from a least squares regression, if we were to compare all of the residuals, meaning the distance above the line for all the points above the positive, and we added all the negative distances for all the residuals below it, they will always, always, always sum up to exactly zero. If you remember, if it helps you remember from when we were looking at the lesson, it was on that last slide where I showed I highlighted everything above the line with a green box and everything below the line with a red box, right? To say that it is just an artifact of when we do linear squares regression, the sum of the residuals is always zero. It's one of those things that is always true, just like that the best, if we do a linear squares regression, the line will always go through the point X bar, Y bar, right? It is just an artifact of doing it that way. That is many times a useful piece of information. So that was kind of a jerk question that you might think, oh, I got to figure out how to run residuals and calculate them in R and then make a loop to sum them all up. You could, and it would come up to zero, but you don't have to, because if you're doing linear squares regression, that is always true. For number 5. So number 5 is another thing we talked about on Wednesday, of saying, when we first introduced the concept of a best fit line and linear squares regression, we introduced this idea of the R coefficient, right? And the R coefficient was this number that went from -1 to 1 that told us basically, hey, we made this line, how strong of a fit is it, right? And we said, if we get a line that has a positive slope and all of our dots were exactly on the line, which, spoilers, is never going to happen, but if we did, then it would have an R of 1. That represents that it is a perfect positive linear correlation, right? And conversely, if we got an R of -1, then it would mean that we have a line with a negative slope and all the dots fall exactly on it. It's a positive, or I'm sorry, it's a perfect negative linear correlation. Anywhere in between is some measure. Like if I get a point, if I get an R of 0.8, relatively strong positive linear correlation. I have a line and the dots are relatively clustered around it strongly, right? It turns out, though, and if you look in your book, we talked about this on our lesson, but it is also in section 8.2.7, if you want a place to go back and look in the book. In section 8.2.7, they talk about this coefficient of R squared, which is not new. It's just that R value, but then squared. And we usually talk about the R squared value more than we talk about the R for a couple of reasons. One, because it's squared, it's always positive, so we don't have to worry about, we're not caring so much if it's a positive correlation or a negative. We're just caring how strong is the correlation. But the other reason we care about it is it turns out that when you square it, for some mathematical reasons that you guys don't necessarily have to know, it has additional meaning, right? It is the R squared coefficient, which you will get when if you run your linear model in your summary statistic. The R squared statistic is one of the statistics that you can pluck from there. But the meaning of that variable is a measure of the reduction in variance, right? So when I look at data, like for example, our revenue variable, or I still have the GR data up. So if we stop sharing this and we go back to this made up example, or not made up, it's real, but where we were comparing our GR2 to GR1, right? I could talk about the variance of this, right? This is probably going to embarrass myself and make a mistake here. But in theory, I could say I would like to do a box plot of GR2. And let me see if it actually, oh, nope, because I didn't bring in grades. So let me go ahead and bring in grades. And now I should be able to go down here and I can do that. Oh, it still doesn't like it. See, I told you this was oh, I'm sorry, of grades $. Let's try that. Okay, so there is my box plot, right? So that gives me a visual representation of how much variance there is in my response variable, right? Because when I look over here, my response variable is GR2. And so this has variance from about 40 to 100, as we can see here, and I can see the interquartile range, right? That being said, though, when I build my linear model, now what I am saying is I can now compare how much do the residuals vary around the line, right? So I am saying, hey, in the response variable, they had this big variation and this spread, but now I can instead say, but how are they spread around the line, right? Because the better a model I have, there will be less spread about the line as far as like what's the farthest they are from my line, right? And so what the R squared turns out to be is it is a measure of how much I have reduced the overall variance originally in the response variable when I compare it to my line instead of just in general, right? Because if all the dots were exactly on the line, then I would have an R of 1, which would mean I would have an R squared of 1, which would mean that I reduced my variance by 100% because there was some variance in the response variable before, but when I compare the distance to the line, there is no variance. And so my line explains all of the variance, or it reduces the variance by 100%. If I were to get an R squared of, say, 0.25, then that's saying, oh, your line isn't perfect, but it does reduce the variance by 25%, meaning my model explains 25% of the variance. When I look at the observations compared to the line versus just compared to overall y value, it explains or reduces 25% of the variance. So that is how you get, that is, where you get your R squared and what it means. It is, and so that's why we use it, because it has this very real, tangible meaning that we can use for saying how much of the variance is our model explaining or reducing. Alec, did you have a question? I'm sorry, I didn't see while I was just going off on my tangent.
Yes, sir. So I'm looking at my summary of my linear model right now. How exactly do I read this? Because if I'm looking for my R squared, it says there's like multiple R squared and then adjusted R squared.
Right. So I believe what you want is the adjusted R squared. Before I put my foot in my mouth and say I'm wrong, let me just double check to make sure I am correct. Avenues, the middle so we should not have to worry about the multiple R. Simply a measure of the R squared model to have multiple particulars, therefore it measures the amount of variation in the response variable that can be explained by the predictor variables. Okay, so you're right. So I believe I appreciate you asking me this question, because I think I said something incorrect before. So I will double check and I will put out a message to everyone. But multiple R squared is what we want to use, because basically what it is the those are the R squared values. You're correct. We are doing linear regression, where we are basically only checking against one variable, in this case, budget, right? We're not going to get into it, but it is possible to do what's called multiple regression, where we're basically saying, hey, I think the revenue is a result of several variables, right? It is the budget has some effect, but also the fame of the actors and all this. And so I have 3 or 4 variables, and I come up with some equation that instead of just y equals mx plus b, I get into this thing of it saying, well, y is equal to, mx plus n z, a bunch of variables. We're not going to get into that. So the multiple r squared is saying, what is the r squared based on all the variables you have? We only have one, so it is just the r squared we want. The adjusted r squared is basically doing a penalty where it is saying, I'm going to, based on how many variables you have and how uncertain I have, I'm going to adjust that r squared value over time so that in theory, I could compare this r squared in a multiple to this r squared in just a linear to give an idea, a fair comparison of how good they are both to each other. But it seems like we don't want the adjusted, the multiple. They should be relatively the same. And I will give you as I do my, I'm going to do a little bit more research here, but it looks like that is a good question and I was wrong. So we are going to use the multiple r squared until I tell you differently. Maxwell, do you have a question?
Sir, I was just going to ask, just as kind of a general thing, can we get like a quick walkthrough, like explaining the summary again? Just kind of going over like
sure. So there is
going on there, since there's
so there is a lot. So there's, and the summary is just the how we say, the summary of what is a giant model, right? This is the GR model. Like I showed you guys before, if I go into, well, I don't have the GR model open here, but I have, this is my movie model. It has all of this stuff in it, right? And so when I look at the summary, it has some top level stuff, and some of it you don't need, some of it you will need, some of it you may never care about, right? So the first is just the call. It's just saying, hey, this is what you did, right? And it's confirming that you wanted to have GRB2 be your response variable and GRB your indicator variable and where the data is coming from, right? Then you have, each thing has a colon saying what we're talking about. So this is the residuals, right? So this right here is saying, here's a summary of your residuals, right? And remember, the residuals are it's made a line, and now it's saying, if we look at the vertical distance of every single one of your observations from that line, these are just some summary statistics about that on the median, quartiles, and min and max, right? So it's saying that your min and max residual are -38 and 30. Well, this is my grades, right? So this is not the movie. This is saying that my residuals at most are 38 points below and 36 points above the line, right? Then we look at the coefficients. Coefficients is where you guys are going to want most of your data, right? And so the estimate column is the thing that we're caring about the most, right? Because again, when we do the linear regression is we're taking a sample to try to get an estimate of what that actual equation is that we'll never know, right? The actual equation is that y equals beta naught plus beta 1 x plus epsilon, right? But we'll never really know what that is. And so we are using our sample to get an estimate of those coefficients by using beta naught hat and beta 1 hat, right? So this is saying the estimate of our coefficients. This is for the intercept, 31 in the case of the grades. And so this is saying this is what our estimate, our estimate of beta naught, which is beta naught hat. And then this is our estimate of the coefficient that goes along with GR1, right? Because in this case, GR1 was our X variable, right? Our indicator or our predictor variable. So this is saying this is the estimate of the coefficient that goes along with that. And so the coefficient that goes along with that would be the beta 1 hat. So that is the beta 1 hat value. These other things over here, standard error, t-value, probability, you don't necessarily need to worry about but those are basically kind of just doing like we would do the hypothesis test for correlation, which we're not worrying about that, right? And so we're talking about saying basically it's trying to do a significance test for correlation of making the decision, should we reject or not reject the hypothesis that this data correlates, right? So we don't teach that, so you don't have to worry about that, but that's what is going on there. Then we have here our residual error. And again, when we talk about degrees of freedom, they're talking about doing a statistic to see whether or not to test correlation. We're not worried about that. The only things you might care about down here is this residual standard error, which is kind of that measure of kind of a sample measure of that epsilon. We don't get into that as much, but it's something that you might use. What you are going to pull out is this r squared, right? You have 2r squared, and like we just talked about, this is the adjusted, and this is the multiple. And I am still reading up here a little bit because I believe incorrectly was recommending people use this one. I think this is the one we need, but I will give you an answer by the end of class. But this is the value of the r squared, which if you were to take a square root of that, would give you the actual R value, which I think in this case would be about 0.4, which means 0.4 is positive. It's in between 0 and 1. So I would say based on this, I have an R of 0.4, which means I have a weak to moderately strong positive linear relation. But since the R squared is 0.1679, I can also use that to say that my line explains or reduces the overall variance in the response variable by 16.79%. Does that hit all the points that you wanted to kind of see what that summary means?
Yes, sir.
Outstanding. Okay, cool beans. All right, let me go back to here and see what I got for questions popping up here. Okay, that looks good. Let me go back to over here. All right, so let me go back. You guys keep working on that. Let me know. I'm seeing some questions on 7 and 8. So a couple things on 7 and 8. So number 7 is that question talking about, can we predict what the revenue for a movie with a budget of 400 million are, right? And so the whole point of making a prediction, a linear regression model, is so that we can do that type of prediction, right? Because once we have that equation, right? Because we get those parameters because we are trying to define that line, right? And the line is our estimate. If we had the actual parameters, then it would be the line that told us exactly what the average Y, which is the average revenue in our case, for a given X, right? And so if we wanted to know what is the average revenue of a movie with a budget of 400 million, what we would want to do is put that X value into the real equation and calculate the Y. We don't have the real equation, but we can use beta naught hat and beta 1 hat to come up with an estimate equation, right? That's going to end up being beta naught hat plus beta 1 hat X equals Y. And because of our X and Y, what we're really saying is beta naught hat plus beta 1 hat times the budget will give us an estimated average value of the revenue for that X. Now, that is technically what we can do. You just put that into any calculator on your computer or your emulator and figure that out once you know what beta naught hat and beta 1 hat is. That said, once you have that number, then you need to ask the question, is that number meaningful, right? Because I would argue that based on what we talked about on extrapolation, there's probably some caveats of saying, do you really think that represents what the average revenue would be for a $400 million budget movie? So I would be curious to see your explanation on that. With respect to number 8, that is a question about leverage, right? And so that's what today's model. Sorry, I just wanted to make sure I don't keep you guys late because this new schedule calls. But I've got you. I have you guys for about another 15 minutes. Is that correct? I don't want to keep you guys. We're here till 13:38, right? Yes. Okay. So leverage and influence is something that was talked about in the lesson that was for today's guided lesson. So if we go back over and look at, where is this? If we look at the book, we can go down to, where is our section on leverage here? So here we go. So when we're talking about types of outliers, right? It goes down here, and you guys, pattern recognition wise, you can look at data and usually say, oh, that looks like an outlier, that looks like an outlier. What leverage and influence, though, give us a way of describing the outliers, right? So they say right here that points that fall horizontally away from the center of the cloud are called, say, high leverage, right? Because it is points that are further away on the x-axis tend to have more leverage, right? Because the further away they are on the x, think of that line as a big lever, right? It was where leverage comes from. And so if you have a point that is right in the middle of the x, it might pull it up and down, but it is not going to tilt the line that much. Whereas if it is far enough far away from the cluster of the cloud on the x-axis, if it is off, it is going to cause a lot of leverage pulling that up and down, right? Now, leverage is different from influence, because if I have a point that is far away from everything on the x-axis, but it falls exactly, if I drew a line just through the other points, and then it falls exactly on where that line would be, it has a lot of leverage, means it has a lot of potential, but it does not have as much influence, because it has the ability, but it is not actually influencing the line. That being said, when a point is either has high leverage or is far enough away in some way that it is actually influencing our line, then we say it has high influence. It is an influential point, right? That is where we use that diagnostic, right? The fourth diagnostic that you run for the condition to say, are these data independent? Where we use Cook's distance and those dotted line. When a dot falls outside of the dotted line, what we're saying is that dot is so far away from the cloud, and it is far away in such a way that it is exerting undue influence on our line, right? It is basically saying that we could have a much better fit through all the other points if we were not tilting our whole line just to make this one dot happy. And so it is acknowledging that there's a good possibility that there's something else going on with that dot, that maybe it is not independent, because we are having to move our line a bunch and mess up what could be a really good fit to accommodate that one dot, right? So that's the difference between leverage and influence. Leverage is basically a far outlier in the X, saying this has the high potential to influence our fit, and if it's actual influence, that means it has actually exerted a high amount of influence on our linear model. And so you should see in our data, if you are doing the analysis correctly, there should be a dot that is exerting high. There's the dot that has the most leverage and the dot that has the most influence are different. And if you look at the one that has the most, if you look at both the movies, they kind of make sense if you think about them. Because I will, I'll be curious to see if anyone figures that out. But the dot that has the most leverage is one of the Pirates of the Caribbean movies, which makes sense. It has a extraordinarily high budget because of just what those movies were, but it has a revenue that's about in line with everything else. And so it is not, even though it has the potential, it is not messing up our line. Whereas the dot that has the most influence is dot number 18. If you do the diagnostic plots correctly, you'll see that dot number 18 is outside of that. And if you look into the data, that is the movie Avatar, which also makes sense that it is probably an outlier, right? Avatar had a lot of special things going on with it. It was the first 3D movie. It was a big hype around it. It was special, right? So it made not only did it have a high budget, but it made way even more than was expected for that budget. And so it is probably not independent. It is not a good representative. It is a outlier. It is special. And it is, our line is being pulled towards that in such a way that if we said, okay, James Cameron's Avatar, that was a once in a generation special thing, we take that out, then our line goes down and we will get a stronger fit, a stronger correlation coefficient if we were to take that out. And then going back, I'm seeing a couple of increased things on number 6. As a reminder, the sum of the residuals, that was a kind of jerk, not trick question on mine, but it's just a conceptual, is based on whenever you do linear squares regression, the sum of the residuals is always 0. And that is just, it's one of the reasons why we do least squares regression. And a couple of people were saying that curious how to find the movies. As a reminder, if you want to, when you look at the plots, a lot of times for special points, they will have the number associated with them. And so if you see that number, you can just go and have R tell you what is that row number, and that will tell you, what the movie is. The other thing you can do is if you look at that your scatter plot and say, oh, this outlier is the furthest to the right. Well, then that means you want to find what is the movie that has the max budget. And so you can tell R to say, give me the row where budget is the max. And that will spit back out that Pirates of the Caribbean movie. And again, just so you guys know, at the end of the day today, I will give you my answers along with my code, and you kind of look at that and tell me if I'm on crack or not. Let's see.
Sorry, sir. Just to double check with 7, did you want us to give you that answer or just like say whether or not we can and how we would?
It's up to you. Like I said, this is not a homework assignment. This is something to work on and go here. And so I would be equally happy if you said, hey, here's why I don't think I can do it and why it would be a bad idea. Or if you said, here's what the model says is the number, just to prove to yourself that you could actually do it, comma, but here's my caveat of, saying, here's what the prediction is, and maybe it is correct, but here's why I would caveat that perhaps more analysis is required before we go into a movie executive's office and say, if you spend $400 million, I promise that you will make $1.4 billion, right? And so it's not necessarily right or wrong. The only wrong answer would be to say, I can promise you 100% that if you spend $400 million, you'll make $1.4 billion, or to say, there's no way I could have any idea with this model to calculate that, right? It's the, what can you do mathematically and what does it mean and what either promises or caveats would you give with it? All right. As we get closer to letting you guys go, I will say that I have 99% verified. I'm waiting to hear back from the course director to make sure I'm not crazy. But that when we're asking for R squared, we are talking about the multiple R squared, because the multiple R squared means something special when we have more variables. But for us, when we only have a single indicator and a single response, we're doing linear like we're doing, then the multiple R squared is the same as just the regular R squared. So that is what we're using. The adjusted, they should be very similar, but the adjusted is not what we want to use. So I will send out a message, because I believe I said something different to the other classes. So I really appreciate whoever it was. I think it was Alec who brought that up, because I have been doing it and explaining it wrong for the last, I don't know how long. So I appreciate that. All right. As we finish up, like I said, I will send out to you guys what I have on here, so you can look at that and tell me what you think or any questions. But again, this was hopefully, let me know directly if you like this kind of class, or if this was annoying. But I feel like sometimes we have the ability to go between lecture and work, but a lot of times we don't get as much of a opportunity for you guys to try stuff out while I am around here. So I want to kind of have more of these lab type classes where we can kind of get to your feet wet. Hopefully, as we go into the next lab, this will give you guys some helpful practice. It won't be exactly the same, but it's the sooner you guys get into R and start understanding where are the sticking points and where are the parts you understand, the faster you can either do the work or get to the questions that you actually have. So with that, I will let you guys know. I know you have a very exciting schedule of calls here. I don't know. I don't know if you guys, when you guys doing your testing, if you guys who got picked for today got poked in the brain this morning, or if they're doing it later this evening. But either way, I was about to say something that was basically a lie. I was going to say that I wish I could be there with you, but I don't. I prefer being back here in my room. But I do appreciate that you guys take the time. And again, gripe all you guys want, but do realize that I've talked to a couple of my civilian friends working in other universities, and for better or worse, I do appreciate that the leadership is making some decisions instead of just saying, I'm sure it'll just be over by next week. So it sucks, but trust me, it could be worse. And I will talk to you guys on Monday. If not before, I'll hang out if you guys have any questions. And then don't forget to get your labs in, and then try, if you can, to enjoy some of the weekend. And I will talk to you guys on Monday.
Thank you, sir.
Thank you,
Indeed.
sir.